All right, welcome back. So today we are going to get into one of the absolute bedrock concepts of computer networking. Seriously, this is fundamental stuff. We're going to figure out how everything on the internet, your phone, my laptop, some massive web server across the planet, actually manages to talk to each other. And I mean, really think about that for a second. It's not just magic, right? It's a super structured conversation. So how does your computer ask a server for a web page? And just as importantly, how does that server know exactly how to respond? What are the rules? Well, to get how machines do it, a great place to start is, well, how we do it. You and I, we use protocols all the time, even if we never, ever call them that. Just think about something as simple as asking a total stranger for the time. There's a script, a set of unwritten rules we all just follow. Yeah, look at the sequence. It's so important. You start with a simple hi, and you wait, right? You're waiting for a specific response back. Another hi. That reply is basically a green light. It's the signal that says, okay, you can proceed. Only then do you actually ask your question. See? It's all about a specific message in a specific order that triggers a specific action. That's the core idea. But what happens when it goes wrong? Let's say you say hi and the other person just snaps back, don't bother me. Well, the protocol is toast. It's broken. You're not going to follow up with, so, got the time, right? Or what if they just say nothing? They just stare at you. After a few seconds, you're going to walk away. That failure, that absence of the expected response, is also part of the protocol. It's a rule that tells you, hey, communication has failed, abort mission. And here's the really big difference between us and computers. We humans, we can improvise. If someone doesn't speak my language, I can try pointing at my watch. But a machine? No way. It can't improvise. Machines need a super rigid, totally unambiguous set of rules to get anything done. And that, right there, is exactly what a network protocol is. Okay, so let's put a pin in it. A network protocol is basically the machine version of our asking for the time example. It's the official rulebook that governs how devices on a network talk to each other. It literally defines the language they speak. All right, so here it is, the official textbook definition. It says, a protocol defines the format and the order of messages exchanged, as well as the actions taken when a message is sent or received. Now, I know that sounds a little dense, maybe a bit academic, but don't worry about it because we're about to unpack this into 3 super simple keywords that make it a whole lot easier to remember. Okay, lean in for this part. Seriously. If you're studying for an exam, this is the part you need to lock in. We're going to take that whole clunky paragraph and boil it down to 3 core concepts that you can actually remember and use. So here they are, the 3 pillars. First up is format. This is all about the syntax, what the message actually looks like. Does it have a header? Where does the address go? What information is where? Then we have order. This is the sequence, just like saying hi before asking for the time. It's the back and forth flow of the conversation. And finally, number 3 is actions. This is the so what part. When a device gets a specific message, what does it do? Does it send a reply? Does it shut down the connection? Does it start a timer? Get these 3 things, format, order, and actions, and you understand what defines any protocol out there. Okay, so let's make this real. How do these 3 keys, format, order, and actions, apply to something you do 100 times a day? Loading a web page. Because this isn't just one message being zapped across the internet. Oh no. It is a very carefully choreographed dance between your computer and that web server. Think about it. Just like you can't run up to a stranger and just shout, "What time is it?" Your computer can't just demand a file from a web server. It can't. It has to be polite. It has to perform what we call a handshake to establish a proper connection first. So check out this flow. Step 1, your PC sends out a TCP connection request. That's its way of saying, hey, can we talk? Step 2, the web server replies with a TCP connection reply, which basically means, yep, I'm here, I'm listening. Now, only after that connection is officially established does your computer, in step 3, send the get message for the actual file it wants. And finally, step 4, the server sends the file back. It's a precise, ordered 4-step dance. You can see the parallel, right? It's a perfect match. The hi from our human example, that's the TCP connection request, asking, got the time? Well, that's the get message asking for the web page. And the answer, it's 2 p.m., that's the server sending back the actual file. It is the exact same logic, just, translated into machine language. Okay, So we've got a handle on how protocols work between just two devices. But the internet isn't two devices, it's billions of them, made by thousands of different companies all over the world. So how on earth do we make sure they all follow the exact same rules? And it's so important to get this. These protocols aren't just running on your laptop and some web server. No, they are everywhere. They're in the routers deep inside the internet that forward all your traffic. They're in the switches in your dorm room or office. They're in the massive data centers that power all your favorite apps. Literally every single piece of the internet is speaking this language of protocols, which of course leads to a massive question. If my Apple iPhone needs to talk to a Google server and the message has to go through a Cisco router, well, they can't all have their own secret private set of rules, can they? It would be chaos. So how do we get them all to work together? And the answer is one simple, powerful word: standards. For the global internet to work as one single connected network, there has to be a publicly agreed upon rulebook, a set of protocols that everybody implements. You can't just go off and make your own special version of TCP or HTTP and expect it to work with anyone else. It just won't. So, who actually makes these rules? Well, the main group is called the Internet Engineering Task Force, or the IETF for short. And what they do is publish these super important documents called Requests for Comments, or RFCs. You can think of these RFCs as the incredibly detailed blueprints that define exactly how protocols like TCP, IP, HTTP, all the big ones, have to work. This is what guarantees that a browser made in California can talk perfectly to a server built in Seoul. So I'll leave you with this final thought. Protocols, they're really the grammar of the internet. They're the shared language that makes all of this complex global communication possible in the first place. Without them, we wouldn't have an internet. We'd just have a bunch of lonely, isolated machines, completely unable to talk to one another. So the real question is, without protocols, would our modern digital world even exist at all?